Talking some more about permutations like you've been doing on the past couple of note sheets, and we're also going to be looking at how it relates to the fundamental counting principle. So first thing I want you to do is get that permutation formula written down again because you'll need it on your note sheet today. So remember, n represents the total number of objects and r represents the number of those objects that we are choosing. The most important thing that you need to remember when working with permutations is that the order matters. That won't be true as we move forward in the unit, so you want to make sure that you kind of associate permutations with order as we're working through that stuff today. So let's go ahead and let's take a look at this first one. So for the first one, it says you're lining your friends up to take a photo during your trip to Mount Rushmore. Over spring break, there are 8 of you, but only 4 can fit in the photo. How many arrangements can you make for the photo? So there's 8 of us, and we're going to be picking 4. So now what we want to do is we want to go ahead and on top we're going to have 8 factorial and then we're going to have 8 minus 4 factorial. So let's go ahead and let's simplify that out. So then we have 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by, well, when you subtract 8 minus 4 factorial, you end up getting 8 factorial divided by 4 factorial. So then on the bottom I have 4 times 3 times 2 times 1. So let's cross those off. So then you're left with 8 times 7 times 6 times 5. So let's think back. So first of all, you multiply that out, you get 1,680 different ways you can arrange that photo. Now let's think back when we did the fundamental counting principle. When you saw a problem like this, we kind of made our dashes. Okay, we only have room for 4 people in the photo, but we have 8 to choose from. Once we choose 1, we have 7. Once we choose 1, we have 6. Once we choose 1, we have 5. They're the same thing. Permutations and what we did with the fundamental counting principle are the same thing. So you can choose what's comfortable for you. I usually just continue to use permutations. It's up to you what you want to use though. So let's take a look at number 2. So for number 2, we have the manager of a coffee shop needs to hire 2 employees, 1 to work at the counter and 1 to work at the drive-thru. So we're trying to hire 2. We have 1, 2, 3 people that are applying for the job. So there's 3, but we're only going to pick 2 of them. So then we have 3 factorial divided by 3 minus 2 factorial. So then I get 3 factorial divided by 1 factorial. Now remember that 1 factorial is really just 1. So all I'm doing right here is 3 factorial. So I'm doing 3 times 2 times 1, which gives me 6. So there's 6 ways you could assign each of those people to different jobs. Let's take a look at number 3. So for number 3, there are 10 finalists in a figure skating competition. How many ways can gold, silver, and bronze medals be awarded? So we have 10 finalists, and we're going to pick 3. So here the order matters because getting gold is very different than getting bronze. So we're going to have 10 factorial divided by 10 minus 3 factorial. That gives us 10 factorial divided by 7 factorial. So let's think about this logically. Everything from 7 on down is taken care of. If you still want to write it out and cross it off, I say go for it. But think of it this way. Everything from 7 on down is taken care of. So what's going to be left? Well, 10 times 9 times 8. That's all that's going to be left because everything from 7 on down is going to be crossed off by that. So it's really just 10 times 9 times 8. And when you multiply that, you get 720. So there's 720 ways that we could arrange those finalists in an order to gold, silver, and bronze. Let's take a look at number 4. So for number 4, it says that a newspaper has 9 reporters. Okay, so available to cover different stories. How many different reporters can be assigned to cover the stories? So the order matters because it's going to be different depending upon which reporter is assigned which story. So we have 9 reporters, but we're only going to pick 4 of them to do stories. So then we have 9 factorial divided by 9 minus 4 factorial. That's the same as 9 factorial divided by 5 factorial. So now when I'm looking at this, I know that everything, 5, 4, 3, 2, and 1, are going to be canceled out by that 5. So left over on top, I have 9 times 8 times 7 times 6. Everything else is going to be canceled out by this guy. So I have 9 times 8 times 7 times 6. That's going to give me 3,024 different ways that we can assign those reporters different stories. Okay. Next, let's take a look at number 5. So for number 5, Ms. Brisky asked pairs of students to read statements in Spanish and then translate them to English. If Ms. Brisky chooses pairs, pairs means 2, so I know we're going to pick 2, okay, from Jeff, Kathy, Chris, Anna, and Madison. Well, that's 5, so we're doing 5p2. So I have 5 factorial divided by 5 minus 2 factorial. That's going to be equal to 5 factorial over 5 factorial over 3 factorial. So then, again, I know everything 3, 2, and 1 is going to be taken care of by that 5 factorial here. So all I have left is 5 times 4, and that's going to be equal to 20. So there's 20 different ways that Ms. Brisky can assign those partnerships. Now let's quickly take a look at a review that you guys are going to be seeing on your practice today. Okay, so it looks like the one on here is a little bit different than on your note sheet. So let's do the one on your note sheet. So we have x plus 2y is equal to 4. And I notice on there you don't have the equals to 4, so add equals to 4. Then negative x plus y is equal to 2. So now we're going to go ahead and add down those columns. So x minus x is going to cancel out. 2y plus y is going to give you 3y. 4 plus 6 or plus 2 is going to give you 6. Now remember, I could just go and add down the columns because I had the same coefficient with opposite signs. So now I'm going to go ahead and solve this for y. So I'm going to divide both sides by 3, and I get that y is equal to 2. So now that I know that y is equal to 2, I can take and I can plug that in for either y up there. So then I'm just going to plug it into the first one. So I have x plus 2 times 2 is equal to 4. So now I'm going to solve this for x. So 2 times 2 is 4, so I get x plus 4 is equal to 4. Then I'm going to subtract 4 from both sides, and I end up getting that x is equal to 0. So last but not least, I want to make sure I write this out as a coordinate point. So first I'm going to write my x, and then I'm going to write my y. So that's your final answer right there. That concludes your note sheet. Go ahead and show me your note sheet once it's done. Thanks for listening.